Today we're going to continue with exponents. We're going to learn two more properties. No, not two more properties. One property. We've already learned two properties. So I want to, real quick, before we begin today's property, I want to make sure you remember what we learned on Tuesday. So what properties did we learn on Tuesday? Somebody think back to Tuesday. What did we learn?
Anything to the 0 power.
Thank you, Kenzie. Anything to the 0 power is 1. So if we have x to the 0 power, that's going to be 1. Okay, that's a property. What's the other one that we learned? Not scientific notation. We did learn scientific notation, but what's the other property that we learned?
If it's a negative root of 1.
Good job. You get a high five right now. Good job. Okay. If you have x to the negative 4, right? You learned something about 0 exponents. We also learned something about negative exponents. With negative exponents, we had to move them, right?
Oh, sure.
If it was a negative exponent in the top, we had to move it to the bottom. If we had a negative exponent at the bottom, we had to move it to the top, right? So what this would happen if we have it, make it a fraction, we'd have to move it to the bottom, so you'd have 1 over x, and now it becomes positive. So those are the two properties we learned on Tuesday. We have an additional property. These properties in this unit build upon each other, so you cannot forget about the properties that you've already learned. So today's homework will include some things where you have to do one of these two properties. Okay, the third property we're going to learn right now is with multiplying. Okay, if you multiply two powers that have the same base, this is what happens. You get, here's an example, 3 to the 5th power times 3 to the 4th power. They have the same base. So what you do to multiply them is you actually add their exponents. So a 3 to the 5th times 3 to the 4th becomes 3 to the 9th. So you keep the same base and you add the exponents. That's the property that you're learning for today. Okay? So let's look at some examples on how to do that. Okay, example 1. Letter A. Okay, we have to rewrite the expression using each base only once. So 11 to the 4th times 11 to the 3rd power. Using this property, they have the same base, so it becomes 11 to the 7th power.
Oh, so that's all you have to do on those?
Yes. Letter B, we have 5 to the negative 2nd power times 5 to the 2nd power.
5 to the 0.
5 to the 0 power, which becomes what? 1. Letter C, 7 to the negative 3rd, 7 squared, 7 to the 6th. They all have the same base, so we keep the 7.
7, 5. Yep, he's
5th
correct.
power, yes.
Yeah, ding, ding, ding.
All right, so that's what we do with that property. Now, the important part is that you have to remember you have to have the same base, okay? You have to have the same base in order to do that. So, let's look at some more examples. We'll kind of take it up a notch here. Okay, example 2. 2 into the 5th times 3 into the negative 2nd power. All right, here's what we do. I want you to understand that when you're working with expressions, you have to look at each individual part of it. So the 2, what is the 2's exponent?
5.
Not a 5, that's the n's exponent.
0.
Do you see what I'm saying? So you have to keep in mind, you have to look at each number and each variable separately. So the 2 has an exponent of 1, the 3 has an exponent of 1. So what you can do is you can actually just go ahead and combine those two. Those are just basically whole numbers, just regular whole numbers. You multiply them together. So you get 2 times 3 gives you 6. And then you can take n to the 5th and n to the negative 2nd. They have the same base.
6
So
n to the 3rd.
Yes, you add their exponents. So you get n to the 3rd.
So you really just multiply 2 times 3.
Yeah.
Yes. Now, you can only multiply those numbers if they have an exponent of 1, though. And I will later show you an example where you can't just multiply the numbers.
How do you know they have an exponent of 1 if they don't have an exponent?
Well, if there's nothing next to them, they don't have an exponent. Then it's 1.
What do you mean
If there's nothing next to
If there's nothing there, there's an understood exponent of 1. Okay? All right, letter B. We can take 5 times 2 times 3 because they all have an exponent of 1 because there's nothing there. So we can multiply them. 5 times 2 times 3 gives you what? 30. fraction because they have to have the same base in order to add the exponents. We have an x, we have a y, and we have an x. Our x's we can combine. If we multiply the x's, we get x to the 1 times x to the 8th power. That gives you x to the 9th. And then y, you just have to write. It has nothing to combine with it. So you just write it next to everything. All right, letter C. 2, 7, and 2, they have no exponent, so that means they actually have an exponent of 1, so we just multiply all three of those numbers. 2 times 7 times 2, what do we get? 28. We can put the y's together. Y to the 7th, and then x squared. We're going to put an example D in here, because I want to show you when you can't just multiply the numbers out. Okay.
Why do you say x squared to the 2, but not like x cubed if it's 3? Yeah.
All right, letter D. So I want you to see an example where you don't actually just multiply the whole numbers out. Let's say we have this going on. 2 cubed
Well, you're good.
x squared times 3 squared times x to the 5th. Okay, write that example out and let's talk about how we would simplify that.
When next just be one. No.
Now, in the other examples, we were able to take the whole numbers and just go ahead and multiply them. Okay? In this situation, you can't. You can't just take 2 times 3 and get a 6 out front. The reason is because they don't have an exponent of 1. They have an exponent of 3 and 2. So what you do is you just pull them out front. 2 to the 3rd power times 3 squared, and we'll figure out a number for those in a minute. Okay? And then the x's would go together, and you'd get x to the 7th power. And then we can simplify the numbers. This is how you would do that. 2 to the 3rd power gives you what? 2 times 2 times 2 gives you... So you get 8 times 3 squared is 9, x to the 7th, which then gives you 72 x to the 7th. So just keep in mind that you can only multiply the whole numbers if they have an exponent of 1, which would mean that there would be nothing written next to them because we don't write an exponent of 1. Why? We just don't. All right, so that's how you do those. Let's look at example 3. We're going to multiply 2 scientific notation numbers. Here's how we do this. You multiply your leading numbers together. So first we're going to multiply 7 and 4. 7 times 4 gives you 28. And then what you do is you take the 10 to the 2nd, 10 to the 5th. They have the same base. They both have a base of 10. So if I multiply those, I keep the 10 as the base, and then I add the exponents. We get 2 plus 5 gives us 7. But we're not quite done yet. Dakota, are we not done yet? Oh, was that Nico? Nico, are we not done yet?
No,
Why?
Let's say no because you just said one.
My decimal's here. I want it here because we need that leading number to be between 1 and 10. So we move it 1 to the left, which means what do I do to the exponent?
Subtract.
Nope.
Plus.
Plus 1. So you get 2.8 times 10 to the 8th power. Now we're done. All right, letter B. Let's multiply 2.5 times 6. What do we get?
3, 9,
15. 15 times 10 to the 11th power.
Yeah.
So we added the 8 and the 3.
Move it to the left.
Then we have to move it like the last one.
times 10 to the 12.
To the 12th, yes, because we had to add 1 to the 11th.
Okay, then we go back.
So that's how you multiply two numbers that have scientific notation.
Get off for Richard.
This is all we have?
No, we got backside.
Oh, all because Richard.
All right, on the back side, we have a word problem. All right, a human body contains 3.2 times 10 to the 4th microliters of blood for each pound of body weight. for each pound of body weight. Each microliter, there's a typo there, that should say microliter, of blood contains about 5 times 10 to the 6th red blood cells. Find the approximate number of red blood cells in the body of a 125-pound person. Anybody have any idea what we do with these numbers?
I
Okay.
do.
Every pound of body weight has this 3.2 times 10 to the 4th microliters. So what could I do with those two numbers if I wanted to find out how many microliters were in the entire body? Multiply, wouldn't we? Yeah. So if we take 125 pounds, and multiply it by 3.2 times 10 to the 4th, that's going to give us how many microliters of blood are in the human body, or in that particular body. And then each microliter contains 5 times 10 to the 6th red blood cells, and we want to know how many red blood cells there are. What do I do with that number? Yeah, we multiply it also. So basically, we're just multiplying by all of our answers, or all of our numbers.
Sure, this makes sense.
Let's think about it as paint.
Blood's fine.
Yeah, I'm down with blood.
You know, I mean, just, you know, if each bucket of paint had a gallon of paint in it, right? And we want to know how much gallons of paint are in 20 gallons, or in 20
There's 20
containers
gallons
of paint. Then there's, right, did we multiply that? Do you see what I'm saying? Like, it's just multiplying. This number gives you how many microliters there are in the body. And if you multiply this by this, you're going to get how many red blood cells there are. So we just basically multiply all the numbers. All right, we have 125 times 3.2 times 5. We're going to multiply all of those whole numbers first. So when you multiply all of those out, somebody want to tell me what we get?
No, because I don't know.
No one has a calculator.
You're the know-it-all.
Except for number 6. I mean, someone does.
All right, when you multiply this out, you get 2,000
Why didn't you just say that?
times 10 to the, what do I do with the 4 and the 6? So 2,000 times 10 to the 10th, but this number is not in proper scientific
You
notation.
gotta move the decimals.
Where do I want to move it? How many
To
places?
the left 3 times.
To the left 3 times,
So it's 2.0x 10 to the 13.
to the 13. Because if we move left 3, we add 3.
Wow.
D, can I go use your bathroom?
That one.
All right, so that's, we've now learned 3 properties now. All 3 of these will be in your homework. So if you come up with an exponent of 0, you need to change that to a 1. If you come up with a negative exponent, you need to move it top or bottom. Okay? And if you're multiplying 2 powers with the same base, you add their exponent. So that's what we've learned so far. Thank you for listening.